Okay, we'll go ahead and get rolling with looking at tissues and the integumentary system this week. So we'll go ahead and start off with tissues. So what is a tissue? Well, we kind of talked about this in the beginning of the semester. A tissue is just a group of cells with a common or related function. Different tissues will work together to form an organ, and most organs are going to contain all four of these types of tissues. So histology is the study of different types of tissues, and those four different types of tissues that they can study are either epithelial, which is kind of like the covering, connective tissue, which is more support, muscle tissue, which is typically going to be more movement or creating heat, and then nervous tissue, which is going to be the control. So you can kind of think of these four general functions as just that, general. There are obviously more to them, but if you had to remember one thing about each one of these four classifications of tissues, it would be these. And so you can kind of see with connective tissue, we'll have bone in there. Fat tissue is part of that as well. Tendons that help connect your muscles to your bones. Ligaments that end up helping your bones connect to other bones. Muscle tissue, we have three different types: cardiac, smooth, and skeletal muscle. Epithelial tissue, there's a bunch of different ones, and these help line your organs, make up your skin. And then you have nervous tissue, makes up your brain tissue. Spinal cord and nerves help conduct electrical signals throughout your body. So starting off with epithelial tissue, this is going to form the top layer of your skin. It'll form a boundary to separate and protect you from the environment. So it's going to help cover your body surfaces and line cavities of organs. It'll form a lot of the different glands and ducts that we find throughout the body. And like I just said, it forms a boundary between us and everything around us. So it serves as protection. So some characteristics of epithelial tissue. These cells are going to be the ones that are close together. They form these gap junctions. So they form continuous sheets. Think of your skin, it's just one continuous layer. Also, epithelial cells lack blood vessels, but they do have nerve fibers, so you can feel things, but blood has to diffuse to epithelial tissue from the connective tissue layers underneath them. And many epithelial cells are going to undergo mitosis or regenerate to replace cells that are dying or sloughing off. And this happens typically every 30 days for young people at least. So there's a high regenerative capacity or a lot of different mitosis going on with these cells. So it's a lot of different functions of the epithelial cells. Epithelial tissue provides the body's first line of protection from physical, chemical, and biological wear and tear. The cells of an epithelium act as gatekeepers of the body, controlling permeability and allowing selective transfer of materials across a physical barrier. All substances that enter the body have to cross the epithelium. Some epithelia often include structural features, allowing specific transport of molecules and ions across their membranes. So you can think of capillaries that help oxygen and carbon dioxide diffuse across. Many epithelial cells are capable of secretion and release mucus and specific chemical compounds onto their apical surfaces. The epithelium, the small intestine, releases digestive enzymes, for example. Cells lining the respiratory tract secrete mucus that traps incoming microorganisms and particles. And then a glandular epithelium might contain secretory cells. And so we'll discuss each one of these functions in detail as they relate to epithelial cells in the different body systems. So notice that when we're looking at all the different types of epithelia in this picture, they have multiple layers, and the simple types only have one layer of cells. So you can kind of think of this system of naming different types of epithelia as a two-name system. The first name being the number of cell layers that's present, either simple, meaning one layer, or stratified, meaning multiple layers. Or pseudo-stratified, where it looks like there's multiple layers, but it's actually just one layer. So pseudo meaning false, and stratified meaning multiple layered, but it's falsely multiple layered. So it just looks like it is, but it's still just one layer. It's just a bunch of irregular shaped cells stacked into one layer there. And then the second aspect of naming would be the shape of the cells. So you can have either squamous, cuboidal, or columnar. And so these are all going to determine the function of the type of cell, and this function is based off of the structure, the shape of the cell. And You'll know that we're talking about columnar cells if we are saying that they're pseudostratified. So there are multiple types of columnar, but if we say pseudostratified, they're automatically columnar. It's the only type of pseudostratified epithelial cell. And so you can see all of these different types of epithelial tissue have their own functions. So simple squamous helps line blood vessels in your lungs and helps oxygen and carbon dioxide go across easily because it's such a thin layer. Cuboidal, it'll be lining in your tubules of your kidneys and glands, help with secretion and reabsorption of water. Columnar, a little bit longer, these are going to line your digestive tract to help make sure that all the nutrients is absorbed, increasing the surface area with villi. We'll get to that a little bit more in the digestive system. Stratified squamous will be the outer layer of the skin, so we need multiple layers just in case damage happens, like sunburn. And then also we have multiple layers because they're all dying as they move to the surface, and so they're just shedding new layers off, or old layers off, and providing new layers underneath. And this is a protection mechanism against abrasion, helping your skin from drying out, keeping it moist. And then you have stratified cuboidal, and you can see this in different sweat glands to help secrete water and ions. And then stratified columnar in like mammary glands to help secrete mucus, and a modified mucus in mammary glands being milk. And then we have the exocrine gland and endocrine glands helping with secretion. And so again, there's a lot of different functions of epithelial cells based on their structure. And so starting off with simple squamous epithelium, these cells are really flat. There's very little cytoplasm to them. They're very thin and permeable, which makes them really useful for filtration or rapid exchange of materials, such as carbon dioxide and oxygen in capillaries that need to be able to diffuse oxygen out of them and diffuse carbon dioxide into them as the blood is flowing across to them. So being thin and permeable allows for a quick exchange of those materials. So we'll talk about simple cuboidal and columnar epithelium a little bit more in the semester, or a little bit later in the semester, I should say. But just as a quick reference, simple cuboidal will be cube or square-shaped cells, be active in secretion, lining the kidneys. Simple columnar cells are going to be literally looking like columns, and they're really active in secretion and absorption. Think of your intestinal tract for simple columnar. And then we have stratified squamous epithelium. These are the surface cells of your skin. And so this is the most abundant and stratified, or of the stratified squamous epithelia, because it forms the outermost layer of your skin. This type of epithelium protects areas that are subject to wear and tear. For example, the skin in a short distance inside every body opening to the outside, like the anus or the mouth. And so this is going to be functioning in protection because it's stratified. There's multiple layers. And you can think of keratinized skin on the outside being dead and non-keratinized on the bottom. So the keratinization aspect of it is basically these cells dying and becoming like an outside layer for protection.